Basically, SolarBeam, it's a dual-axis parabolic dish. We have two patents on the system. One is for its celestial tracking, and the second one is on a curvature of a dish itself. It's not really true parabolic dish. We call it a quasi-shaped parabolic dish. What it makes the product so unique, it allows you to compensate for imperfection in manufacturing and as well imperfection when you are putting the system together. So your efficiency will be as good as you expected in your simulation. So that's why we took that route, and basically what the dish does, or solar concentrator does, it follows the sun and harvests energy from the morning until sunset, and it's perfectly perpendicular to the sun, so the focal point in a dish actually harvests that. What's unique about the dish itself, our absorber is only 10 inches by 10 inches, and we are producing in that focal point up to 11 kilowatts of energy, or 36,000 BTUs of energy. The unit itself is roughly 8 feet tall as far as the post is concerned, and the dish itself roughly 16 feet in diameter, which is roughly 160 square feet, and basically it replaces up to 15 flat panels technology, or 400 square feet of flat panels. So especially at temperatures around 200 degrees C or Fahrenheit. So as far as the technology is concerned, this is the most efficient product because the temperature or efficiency of a dish itself is not dropping drastically as it happens with conventional system. And secondly, the most important part is there is no heat stagnation in our design. So when the temperature of a fluid reaches 200 degrees Fahrenheit, our dish automatically, it will get out of a focal point and will stay there until the temperature subsides by 10 Fahrenheit. So it will never be a situation that you overheated the system. In fact, you can use PEX as a connection system instead of copper tubes or equivalent of. So having this as a device, we can actually compete very easily in a marketplace where somebody is looking for high temperature applications like temperatures around 200 Fahrenheit, or absorption chillers when we want to create a air conditioning effect. So having these two aspects, it makes us really a leader in that field. And down the road, the unit will be capable to produce as well electricity. It's a hybrid system, in fact. It will produce heat and electricity and can be utilized both at the same time, or can use cooling and electricity at the same time. So that makes the product very interesting. We are not really aiming for utility scale. It will be actually the decentralized system, which will be sold to applications where you need 5, 2, 1 or 20 units, and depends on the situation. Somebody wants to have 200 kilowatts, or somebody wants to have 11 kilowatts of energy produced. So we can scale it down, and the idea is to sell the product not only in the United States but as well worldwide. The unit actually, as you know, is following the sun, so the speed of the horizontal movement is very slow, and in fact the system moves every 0.1 degrees, so it's not continuous. So I would say every 2 years, if you need to lubricate the slew drive, this is the part which makes the dish move horizontally. That's all it would be really needed. So for maintenance cost, I would say over a period of 10 years, if you spend $200, $300, maybe that will be it. Not at all, as long as there is a reasonable distance from objects, such as buildings, and we recommend typically a radius of 20 feet, so that will give enough space for the system to operate safely. And the unit is equipped with a lot of warning labels, so you don't come and don't climb and so forth. Typically you will have the same situation with power transformers. And there is a warning label: don't touch, don't climb, and beyond that, we don't see any more major problems. The system is designed to operate up to 45 miles per hour, and automatically will go into a stowaway mode, safety mode, which will allow the dish to go to a position that it can survive higher winds. In stowaway mode, it can go up to 200 kilometers, which is roughly 105 miles per hour. So we use actual state-of-the-art simulation package made by SolidWorks. The system allows you to look at the components, at the component stress as the wind is applied, and see whether we are exceeding or meeting our requirements. The rule of the thumb in our application is whatever piece of the material we have, it has to be stronger 3 times than the maximum wind load we are talking about. So there is a safety factor of 3 times for every component we have it in our system. Definitely everything depends on the solar resource. But let's for example pick something like Arizona, and with a program they have available, you could be as low as 3 years, and it could be as high as 6 years. Well, we sold the project throughout the world, and in fact we shipped the units to Germany, to Austria, to Italy, Oman. Believe it or not, Middle East is extremely interested in our product. We shipped a number of units to United States and Australia. And right now we are working with a company from New Zealand to purchase our systems as well.
Sunshine Coast, coral reefs, the Great Barrier Reef. This is Australia. This is the place where we're testing our SolarBeam concentrator system. Right now what we're doing is we're tipping the dish down so that we can focus that solar radiation, that sunlight, into that focal point. One of the most unique things about the SolarBeam concentrator is the ability to track the sun on a dual axis system. What we do with this system is that as we track the sun reflects its energy on the reflective material, which beams that light into a focal point. This focal point is the receiver which generates all that energy.